So the next thing we're going to talk about is linearity of systems. So a system is linear in a little bit different terms than a function. The main thing about system linearity is the property of superposition. So superposition. If superposition is found to be true, then the system is linear. So superposition has two parts: additive. The additive property is that if you have a system H that's acting on signals x1 and x2, then this is going to be equal to the same system H acting on x1 plus the system H acting on x2. Second property of superposition is homogeneity. This property states that if you have some system H that is acting on a constant multiplied by a signal x, then this is going to be the same as that constant multiplied by the system acting on signal x. So these are the two main properties of superposition. So how do you test for linearity of a system using superposition? Said, if you have a system if you have a system H where the input is a signal X and the output is a signal Y, then for any input where x of t is going to be equal to a1 times x1 of t plus a2 x2 of t results in an output of y of t, which is going to be equal to a1 y1 of t plus a2 times y2 of t. This is going to be true for all a1, a2, x1, and x2. So meaning this rule can be applied. You're not just going to pick one scenario in which this works. This has to work for all constants that you can move outside the equation and move through the system in this manner. So superposition has two properties, additive and homogeneity. This is basically the distributive property of addition and the commutative property of multiplication. So if these hold true, then it is linear. And the specific definition for linearity is written out here. So now, let's look at a couple of specific systems. So if you have, consider a system where you have x is going into, wrong place. So let's say that we have y of t is going to be equal to x of t. This is going to be raised to the power of p. So another way of writing this is that x of p is t. Okay, so this is the system. This is the input. So, is this system linear? So, how do we check this? Let's just choose a value for p. Let's say p is equal to 2. So now, we can write this out graphically in order to conceptualize this first. So if we have x1 is going to go into the system H, this is going to result in the sum with x2 going through the same system H, and this is going to result in, I'm going to call this output y super. This is a superposition. So we're saying that if we say x is now x1 and x2, the superposition states that if you send them both through the system individually, then sum them at the output, we get an output value. And that should be equal to, so this is the question for superposition, that should be equal to x1, x2, that we first sum and then put through the system H that results in y, and I'm just going to call this system. So if y of system is equal to y of the superposition, then this passes one of the checks for linearity. So is this true? So let's take this and apply our system. So we have x1, which is going through the system. The system is x to the power of p, where p is 2. And so we have x1 squared of t. This is x1 being applied to h. And then we're going to sum that with x2 squared of t. This is equal to y of superposition. Now, is this equal to this output system? So we have x1 and x2, x1 of t plus x2 of t. Now we're going to apply the system to this, where p is equal to 2, so we're going to square it. And this is going to be y of system. So now if we multiply this out, we get x1 squared of t plus 2x1 of t, x2 of t plus x2 squared of t is equal to y system. Are these equal? x1 squared t, this has this other quadratic term in it. x2 squared of t. These are not equal. The system is not linear. Now, from our previously known definitions of linearity in mathematics, we can pretty much see from the input we're squaring it. It's not linear. So, this system is not linear. Not linear. It fails the test for, I gotta make sure I spell this right. Sorry, losing my notes. It fails the additive property of superposition. Okay, not linear. Does this make sense? Okay, now we're moving on to the next example. Let's consider another system. We've got x, which is going into, this time I chose to call the system G, just for a little bit of variety. The output we're going to have is a y. So, again, I'm going to write an equation for this now that takes into consideration the input signal, the output signal, and the system that is applied to the input signal. So, y of t is going to be equal to 3 times x of t plus 5. This is the system G, and this is the input. Of course, y of t is the output. Okay, now is this one linear? We're going to do the same thing, but we're going to apply the other property of superposition. And so what we're going to look at is whether A times G as it's applied to X is equal to G as applied to A times X. Alright? So this is the first one we want to do. We want to multiply A with the output of the system. So that means we're going to have A, which we're going to multiply with the output of G, and G is taking X in. And we're going to call this again Y super. On this side, we have a much simpler scenario. We have A that is going to be multiplied by X. This is going to all go into G, and this gives us the output Y system. Alright, are these the same thing? Let's write an equation to represent this flow graph. Okay? So, A times the quantity, all of this. We're going to look back up at this equation, which is the equation of the system. So A 3 times x of t plus 5 is equal to y super. And we're asking, is that equal to? This system is now going to be inspected. And so this is 3 times quantity A x1 of t, or x of t, plus 5. See the difference? This multiply is being done, and all of that is the input to the system. So we're doing a substitution with the input of A times x of t. Alright, now let's solve this out. The A gets distributed inside the parentheses, so we get 3A x of t plus 5A. And is that equal to A, or 3A, let's keep it in the same format, 3A x of t plus 5. See that on this side we have the term 5A. On this side it's just the term 5. So this plus 5 that's on the outside makes this a non-linear system. So not linear. Now this is a little bit misleading because this would be a linear equation, but it is not a linear system because it fails this property. Alright. Got one more example that we're going to go through. Okay, so again, we have a system. X is going into, and again I went back to H, we're going to output Y. Now Y is going to be equal to the derivative of x of t dt. And I'm going to put y of t. Alright, this is the system is a derivative. So this system applies a derivative to the input. Is this linear? Alright, first thing that we're going to do is say h of a times x, is this equal to a h of x? Let's draw out some flow diagrams for these. So we have a multiplied by x. This is being applied to h, and the output we're calling y sys. And is that equal to this one, where we have a multiplied by x feeding into h. This gives us y super. Okay, now again you can see these are the exact same flows as we had on the last example where we were just testing this theory. Alright, let's write an equation for this. Y sys is going to be equal to a times x passing through this system. The system is the derivative, so we're taking the derivative of all of this with respect to t. On the other side, we have the y superposition of t is going to be equal to multiplication of a times x going through the system, dx of t dt. Are these equal? The derivative has a multiplication property, or a commutative property, excuse me. So this is equal to a times dx of t dt. That and that are the same. It passes this check. So, by the first property of superposition, it passes. Let's try the second property. I'm going to try to fit this all on the board. I don't know if I can do that. We'll see. So this is by homogeneity. It is linear. So now let's take and test the second one, which is h acting on x1 plus x2 is going to be equal to h of x1 plus h of x2. This side I'm going to draw a flow graph again, where I have x1, x2. These are going to go into a summation. The output of that summation is going to pass through the system h, and we're going to call this y of system. On this side, we're going to take x, pass it through h, and we're going to take x2, pass it through the exact same system h. We're going to sum the output. This is y super. Okay, let's write the equation for this guy. So we have x1 plus x2 is feeding into the system. The system is the derivative. So this is the derivative of the quantity x1 of t plus x2 of t dt. This guy, x1 is passing through, x2 is passing through in parallel. We're summing the output, so therefore the derivative of x1 of t dt plus the derivative of x2 of t dt is equal to y super. Now, I'm going to write it over here just because I'm out of room. Let me make sure you can actually see this on the camera. Yeah, good. Okay, so this simplifies to the derivative of x1 of t dt plus derivative of x2 of t dt. Sorry that it's so sloppy down here at the bottom of the board. The derivative, you can distribute these out. So distribute the differentiator inside the parentheses, and it splits into the exact form. So, by the additive property, it is linear. So, because it passes both of the checks, this system is linear. So the derivative system is a linear system. All right.